We don't need the nightmare of a rudder failure on our next ocean passage. This boat is 44 years old, and with that alone, it gives me great concern about what's going on inside of that rudder. So let's dig into it and see what we have.
Is it going now?
Yep.
Hello, we are Patrick and Rebecca Childress, and this is what we did to our rudder to make sure it's not going to fall apart halfway across the ocean.
Let's get started. Okay, one more time.
Hello, we are Patrick and Rebecca Childress, and what?
Oops. It really isn't that hard to remove the rudder from this boat. It just takes a bit of time. But first we have to dig into this starboard locker and get everything out of it to gain access to the very aft end of the boat and disconnect the propane locker drain that drains to the outside above the waterline. The next step is to get everything out of the propane locker, both tanks and everything that's stored in there, undo the mounting screws that secure it to the frame, and then loosen up all of the caulk and sealant that seals the propane box to the fiberglass surrounding. Pry that up and get the whole box out of the way. And that'll give us access to the whole aft end of the boat and easy access to the rudder and all of its connections. I had to get out the vacuum cleaner and clean up all of the dust and corrosion left over from the copper ground plane for the single sideband radio. We just don't use it anymore. If we resurrect it, I'll just hook up a ground wire to a bronze through-hull fitting. Satellite communications have pretty well taken over all of our long-range communications. I can tell you from a lot of frustrating experience, it's far better to mark everything in its orientation to each other before disassembly of any of the steering components. These parts can go back in any number of ways, but they have to go back in the same orientation as when they came out. Also, where the steering cable sits in the quadrant is very important to mark. In our boat, the steering cable on the starboard side sits in the lower slot, and on the port side, the steering cable sits in the upper slot of the quadrant. It wasn't really my intention to show how to get the rudder out of this boat. It's something of an afterthought. So some of these scenes are a bit in retrospect of actually when we put the rudder back on. But it'll give you a good idea of what we had to do to get this rudder out. So before taking the bronze boot off of the bottom of the skeg, or before we disassembled any of the steering or other mechanisms inside the lazarette area, we set up a line that goes underneath the rudder, then up to the port side and the starboard side of the boat, and then forward to a winch on both the port and the starboard side. So once everything was disconnected on the inside, it was very easy then just to lower the rudder down into a hole that we had dug in the sandy soil. Then we could carry it off and start digging into the rudder and see what its condition on the inside is. I won't show you everything that I did to inspect this rudder shaft because it would just take way too long, and besides, what we're doing at the very bottom end of this rudder is very representative as to what was done on the top end of the rudder shaft. I wanted to open things up, check out the spline to rudder shaft connection, and also dry up the areas because I know water was getting into this rudder from the top and the bottom end. So I want to seal both the top and bottom end with epoxy just as good as I can to make sure that no water can get back into this rudder in the future. I was using a diamond studded blade on the angle grinder and holding that on just as much of an angle as I could to cut this slot that I'm trying to now pound out with the hammer and chisel. I wanted as much angle as possible to make it easier for sanding later on to get an even greater bevel for proper fiberglass adhesion when all of this is reassembled. So I already cut a similar slot on the other side of this rudder. Now I just have to pry everything out and break it free from the close cell foam that's on the inside of the rudder and whatever else might be holding it in place. So this is what I cut out from the leading edge of the rudder to inspect the welds on the plate that attaches to the rudder shaft. So it turned out there was just a lot of putty in here, and then that was overlaid with what looks like maybe 2 layers of fiberglass cloth. So it wasn't a very strong structure, and it's been known with some other Valiant 40 owners that they would get a crack longitudinally along that leading edge and also on the trailing edge. So now it's a matter of vacuuming up any rust particles that are in here and then cutting back this closed cell foam. It's really tough foam. It isn't hard, it's rubbery, but still very strong and very difficult to cut with a razor blade knife. And then once we get this all opened up, I'm trying to cut it back to where there's a dry area, but in any case, we'll set up a hair dryer in here on low temperature and let that blow for overnight and help dry anything else that maybe we aren't seeing. So I got out the electric drill and some wire wheels and started polishing away. I was very surprised. I thought this whole area was just going to be one big, soft, rusty patch that was going to fall apart into nothing right before my eyes. But there was still a lot of good integrity left in this spline and the rudder shaft attachment. That was a very pleasant surprise. You can also see the welds. They are polishing up very nicely as well, and they aren't just disintegrating into powder. It's a long way to reassembly, but this was a good time to get out the grinder with 40 grit paper and open up the bevel on this area of fiberglass so that we'd have a good wide area for the new fiberglass to adhere to upon reassembly. At this point, I still dug out even more foam because the very special filler I want to put in here, I want to be able to go underneath the existing fiberglass, which will create a much stronger join when the new layers of fiberglass are installed over the top. Because of some of the deterioration of the spline, I was just barely able to get the tip of a fingernail between the spline and the outer edge of the weld. But out of curiosity, we decided to go ahead and just grind away the entire weld and just check and see how things looked. And actually, it was all very strong. But at least now we know, and all the welds disappeared with the grinder, and we would install all new welds in this section of the rudder. Both sides of this spline got new welds, and this makes me feel so much more secure, so much more confident about this 44-year-old rudder. The bottom of the rudder shaft is now looking great. The top of the rudder shaft was good. There's no sense in ripping anything out in the middle.
Finished.
All right.
Now the rebuild begins. First I want to lay in a very thin coat of epoxy resin, slightly thickened with Cabosil. I want this to soak into all of the cracks and crevices and crannies and then build up from there. Layering in these fillers, time is of the essence. I want a wet on wet application. That is, I don't want one layer that's in there now to harden up past a tacky state. I want the new layer to adhere to a nice tacky previous layer. If I wait for everything to harden up, then I could have a cold joint, and it's just too hard to get into these tight places to sand them properly to have a good mechanical joint. The next application is more epoxy, but it's made thicker with even more Cabosil mixed in. Now for the big stuff. Little styrofoam balls, kind of like what you'd find in a beanbag chair. And this will be mixed in with the epoxy. It'll be nice, it'll be lightweight, it'll take up a lot of space. But first, I want to mix in some Cenolite, C-E-N-O-L-I-T-E. This is a silica aluminum product, tiny little spheres. It feels like and looks like sand. So this will help to thicken up the epoxy and take up the space in between the styrofoam balls. Let me show you 1708 fiberglass cloth. It's a biaxial woven cloth. It's very strong, but especially on the back side it has chop strand mat. This chop strand mat is sewn on with threads. It isn't glued on. Normally chop strand mat laid out flat will be held together. All those oriented strands will be held together with glue. That is not compatible with epoxy resin. This being sewn on, there's no problem at all using it with epoxy resin. And I always apply the 1708 chop strand mat side down. Good strong cloth, been using it everywhere on the rebuild of our sailboat. On this project we are using Gurit LR30 laminating epoxy resin. I'm not setting the best example here handling this cloth with bare fingers. Oils from the fingers can transfer to the cloth and then inhibit proper adhesion of the fiberglass resin. So it's really best to always wear rubber gloves, whether it's latex or nitrile, whenever handling fiberglass cloth or resin. All the pieces of fiberglass cloth are all pre-cut. It makes it so much faster and easier to have everything just set up and ready to go. And we put on a couple pieces the same size to help fill up the void, and then each piece of cloth after that is a little larger and starts expanding out to that beveled area of the rudder. It was a lot easier to wet out the cloth on a horizontal board and then lift it up and carry it over and slap it on down onto the repair area and roll it out with a fin roller to roll out any air bubbles and excess resin. Layer after layer after layer went on. I lost count of how many layers of fiberglass cloth went on to fill up this patch. It's just amazing. It takes a lot more than what you ever expect. Now there becomes the complication of applying too much epoxy resin too fast and building up too much heat during the hardening process. The last thing to go on is peel ply, and that'll go on just as though it was another piece of fiberglass cloth. It'll be wetted out except around the edges so that it can be grabbed and then peeled off when everything is set up the following day. And along with that peel ply, any of the amine blush, which is a reaction between the hardener and the surrounding humidity, will come off with the peel ply. If that doesn't happen, then amine blush will act as a release agent and cause all kinds of complications down the road. But of course the amine blush can be washed off with some water, some soapy water and a lot of rinsing, and then scuff up the surface with 80 or maybe 100 grit paper, and that'll give a good mechanical bond if the peel ply isn't used. So then we get out a straight edge and check to see where the high spots are, the low spots, see if we need to add more fiberglass cloth anywhere, or get out the putty and start the fairing. So after laying in more layers of fiberglass into the very low spots, puttying some of the not so low spots, and sanding the very high spots, it's time to check the levels again. So now we mark the high spots and we'll grind those down and just complete the fairing process until we have everything just right. The fairing compound that we use to build up the low spots is a two-part epoxy compound called Seafair 600, and we bought that from AMT Composites in Durban, South Africa. Good stuff, easy to sand and easy to mix, much better than mixing up our own epoxy resin with a bunch of fillers. One more project to do on this rudder is to lay in a couple layers of fiberglass along the trailing edge, the skinny edge of this rudder. Seeing how the leading edge just wasn't built that terribly strong at the factory, I just want to make sure we don't ever get any cracks along this trailing edge. So I'll lay in a layer of 1708 and then on top of that some very lightweight traditional weave boat cloth. And then after everything is sanded down and faired out, everything should be ready then to lay this rudder flat and start laying on a couple coats of epoxy resin as a barrier coat. and then it'll be ready for remounting. And of course, peel ply is the last thing to go on to the trailing edge of the rudder. And it is finished, better than ever and ready to go back on. It really isn't difficult then to put the rudder back in place. We just drop it down in the hole on top of the rope that's going to hoist it up. And Talente actually has the hardest job holding that shaft in place and guiding it up through the rudder log, while I just give a little crank on one side of the boat and bring it up a bit, and then go to the other side, the other winch, and give that one a crank, and slowly, slowly, back and forth, we raise that rudder up into its place. And once the rudder shaft comes up through the shaft log, then I can start slipping on all the components that'll help to keep the seawater out of the boat. And at the very top end of the rudder shaft, that's where the bearing, the upper bearing, will be fastened, and that's good. The whole weight of the rudder then can be hanging from this upper support. But we're not going to let that happen just yet. We'll keep the rope underneath the rudder just to give it a little support while we do the rest of the work of the assembly. Once the bronze boot is properly bolted in place, then we can take away the blocking that was helping to support it during that installation, get rid of the rope support under the rudder, and start filling in the hole in the ground. What just took 16 minutes to show took over a week and a half to do, but it was well worth the effort. Now I know just how solid our rudder is. We know several cruisers who have lost their rudders far out at sea. It's a terrible ordeal to have to live through and work through. One cruiser that we know lost their rudder, their spade rudder snapped off halfway between Bora Bora and American Samoa. We were fortunately upwind from them at a coral atoll. We were able to gather some lumber together and deliver it to them out in the middle of an ocean. So they fashioned together a makeshift rudder, and as soon as the wind picked up, it just didn't work. It kept breaking. So they spent another month working their way 630 miles to safety in American Samoa. At least now we have great confidence we'll never have to live that sort of an ordeal.